Hey guys, welcome to another video here on the AviationPro channel. In today's video we're going to take a look at the electronic flight bag, or the EFB, in the Boeing 747-8 by PMDG. Now the EFB is of course a relatively new feature to the Boeing 747-8 aircraft, and it's probably going to be included in other PMDG aircraft in the future as well. And it's very handy and realistic utility that pilots in the real world also use for various applications. So we're going to take a look at it, and we're going to take a look at it in conjunction with a flight plan, the same flight plan that I used for my flight from Dubai to Lisbon a while ago. I'm going to use the exact same flight plan, and with that we're going to program the FMC and then take a look at all the EFB functions, and I'll kind of explain the EFB step by step as we go through the different systems. So as you can see, we're standing here at stand Charlie 34 at Dubai, and basically right here in the 747-8. By the way, this is a cargo aircraft. This is the Boeing 747-8 freighter version, and in this 747-8 you will find the EFB on the captain side here on the left, and then on the first officer side here as well. Alright, so you will not find it in the classic 400 747, it's only visible in the 747-8. So in order to work with this, I'm just going to show you how I usually set up a flight, and then we'll take a look at the EFB. Usually when I get aboard the aircraft, I load these short panel states with the APU running, so I can really start programming the flight management system right away. I've programmed the flight to Lisbon in this case already in the FMC. Now I've made a separate tutorial and a separate cold and dark plus FMC setup tutorial, so if you really want to learn how to set up the FMC, make sure that you take a look at there. But in principle, you want to make sure that first of all you load the aircraft with the correct amount of fuel and payload according to your flight plan. So in this case, as you can see, we're carrying about 122 kilograms of fuel, and then also make sure that you set the payload according to your flight plan, which in this case about 303 tons of kilogram. The next thing that you want to make sure is of course that you have a route, so make sure that at least the origin and destination are in there. And the reason why I usually program the FMC entirely, from start to finish before I look at the EFB, is because the EFB will copy data from the flight management system into the EFB itself. So I just fill it in right here, and then the EFB will load the data from the flight management system in order to do its calculations. Okay, so that's usually what I do. So after you've programmed the flight management system according to your flight with all the correct data according to your flight plan, then it's time to take a look at the EFB itself. So again, EFB stands for electronic flight bag, and it basically is a separate computer that allows you to do things like view documents, do quick calculations, but also to do calculations regarding your takeoff and landing, and also to view charts if you want to. And then in the background there are also some simulation options that are associated with the EFB. Alright, so we'll just take a look at it. As you can see, this is the main unit. Basically, like the flight management system, you have here line select keys, and right here you have different buttons. You have the main menu, which takes you to this menu right here where we're going to work from. You have a previous button to return to the previous screen. You have page up and page down to scroll through the different screens if they are there. For example, in documents, you have the transfer button, which you can use to transfer your display to the first officer side. And this is useful if you, for example, quickly want to show some information to the first officer, but in practice, of course, you wouldn't really use this. And the enter button can be used to, when you put in information that you can, confirm that entry. Here you have the power button. It does turn the display off. It doesn't really turn the EFB itself off. It will be running in the background as soon as you start the aircraft up, but it only turns off the display. And with the display you can also dim and bright it, so depending on the conditions, for example when it's night you can select it nice and dim, or in daylight you can select it nice and bright. Okay, so let's go through all the functions that we can find here on the main menu. Now the EFB does come with a manual, so I definitely recommend to read it. There's some stuff that we probably won't cover in this video, so make sure that you give it a review. But first of all, right here you see, for example, a memo. That's a little warning that reminds you that you have to visit this page. So you may see a memo light or a fault light appear on the EFB, so make sure that you're aware of that and don't freak out when you see that. It's very normal. So first of all, let's take a look at the documents side of the EFB. So the EFB can be used to view documents and charts. Now right here we have terminal charts. The thing is that you can use a Navigraph subscription in order to view charts on this display. You need a Navigraph account for that. So if you click on this button, a Navigraph window will pop up, which you can enter your account information, and when that's all correct, you will be able to access all the charts that you would normally, for example, view in the Navigraph application itself. So when you've logged in using Navigraph right here, you'll be able to set up your route so it knows from which airport it has to use charts from. Now if you go to the main menu and if you would initialize the flights first, likely this will already be filled in. We'll go and discuss this a little bit later. But in any case, for example, in our case, we've already filled in the FMS, so we can click use airports from FMS. So the system knows that we've planned a flight from Dubai to Lisbon, so we can simply click this button and it will show which airports we follow along our route. You can also enter alternates. So for example, let's say Madrid is our alternate, we can enter that right here. So when that's all set up, you can click the complete button, and this will take you to the page where you can view the different charts. So for example, from Dubai or from Lisbon, or for example our first alternate, Madrid. Now the way this works is kind of like a clip, so like an actual where normally you would have a little board with a clip with paper charts. Right here you can also decide which charts you want to view per airport in this clip, so to speak. So by default you can see the airport ground chart right here, but if we go back right here, you can also edit other charts. So right here you can make a selection what kind of charts you want to view. All these icons mean different things. So here we have airport and ground charts, or airport information. Here we have departure charts. Here we have all the arrival charts. Here we have the approach charts, the final approach charts, any notices and information, but you can also view all the charts, and then using page up and page down you can scroll through it. Okay, so let's say for example, we're going to be flying the Redap 1 Foxtrot departure today, so if we have the ground chart already, that will be fine, but we want to have the departure chart also right here, so we just click that. It's now been check marked, and then click complete. As you can see, right now that chart is now visible and it's added to the clip. Alright, pretty straightforward. We can do the same for Lisbon and same for alternate. You can just edit the clip, add any chart you want by using the filters down here, and then click complete, and then you'll be able to view the charts from there. So if we look at our departure chart, for example, we can use the scroll wheel to zoom in on the chart, and then we can use the mouse and hold the mouse to take a look at the different segments. There's a little menu which you can use right here to access some other functions like night mode. It's very useful to view the chart in the different modes, and especially at night is of course much better visible. You can also rotate the chart if you want for some reason, for example to read some more information. Some charts are oriented a little bit weird, so sometimes it helps. You can reset the zoom. You can also zoom in on a particular part of the chart, like that, so very closely. So yeah, it pretty much speaks for itself. It's pretty useful to this way. So if we go back to the main menu, you have here the documents folder. So if we access that, you have some manuals. So indeed the EFB manual is actually here, and you can easily, if the PDF contains menus, you can easily scroll through this document. It's very, very useful. So you can easily read any information that you may need, for example, on how the charts function works. Now in the documents application, you can actually load any PDF that you want. Of course, they only included the PDFs that are only relevant for the PMDG aircraft, but you can actually, using the manual, if you just read that, you can actually add PDFs, which then will show up here. Okay, so that's pretty useful. You also have a little bit of a menu right here, which gives you some further options to search between documents and to view your history. Then lastly, in this section, we have the video section. If you use a passenger version of the 747-8, right here you will be able to view so-called cameras. Now, of course, in reality, this is useful to make sure that everything is okay, especially close to the cockpit door. In the cargo version, this is not included. And as you can see, it's a little bit laggy. It's just for fun, to kind of give you the idea that you're actually looking into the cabin from the cockpit as you would do in real life. Then over to the next section, we have the pilot utilities. This is very useful to do anything like calculating stuff, converting units, for whatever reason, you can do that all here, or you can simply access a little calculator. You could also open up a scratchpad so you can easily enter any information. Now in the EFB you can type using the mouse and just hovering over the mouse over this virtual keyboard. You can also click external keyboard, and this will allow you to type using your actual keyboard. Problem with me is that I actually have programmed a lot of buttons already to my keyboard, so usually I just use the actual keyboard in the EFB. So if you want to know, for example, how much 10 kilograms of fuel equates to how much volume, you can easily calculate that here. For example, when you're presented with a flight plan for some reason that has different units, you can all do those conversions right here. So that's very useful. Also speed, for example, if you want to have a nice idea of how fast you're actually flying, you can really easily see that here. So all these pilot utilities are really there just to help you with any of these quick conversions or calculations. So pretty useful, and it's very nice that PMDG has actually added all these functions. Back to the main menu, right here we have data load, and basically, as you saw, there was a little memo. Using this function you'll be able to read data from your airport sceneries and add-on sceneries, and this is useful because PMDG uses that data to display the airport map on the navigation display right here. So if we zoom in right here, as you can see, we have here an airport map of Dubai, and the PMDG aircraft is actually drawing that map using information from the scenery files, or the so-called FCAT files. So in order to accurately represent your add-on airport, for example, right here we are at Flight Tampa's Dubai, you actually need to make sure that you let the EFB load the information from that add-on scenery so it can accurately display where all the taxiways and runways should be. Okay. So right here you can simply click on load. Here's some information. Every time you install a new airport, it will basically give you the memo message, making sure that you are, that you have all add-on airports that you may have installed loaded into the system. Depending on, of course, how much airport sceneries you've actually installed, it will take some time. And when it's completed, the memo message will also tell you to restart the application. So let's give it a go. Indeed, Flight Tampa Dubai has not been initialized actually. So let's click yes. And as you can see, it will now actually scan through all the folders. Alright, so when it's finished, you can see application data has been loaded. Click complete to restart the application. So we'll do that right now. And basically this means that the entire EFB has now been restarted, and as you can see, the memo message is gone, so we don't have to worry about that anymore. Now before we go to the flight setup and performance calculations and all that stuff, there are two more pages to look at. Here we have the Ident page, which shows you some information about which model you're using, and if you have your Navigraph subscription active or not, and which ARAC data you're using. And also right here we have the system page. Right here you can see any faults that may show up. For example, when a document is missing from the document library using the document function, it cannot find a PDF that was previously there. It will show up here and then you can take care of it. If you click on EFB maintenance, right here you can do some configuration of the airport scanning that we just did, so you can determine what the minimum runway length has to be for the airport to actually be loaded. And yeah, I just left this all at default. There's also some options regarding how fast you will scan all the add-on files. Okay, so you can take a look at this. Here we have the application preferences. You can basically set a lot of things right here. Make sure you actually read the manual, so you make sure that you are aware of what you're clicking. So you can basically set the nearest airport criteria. You want to make sure that you set a minimum runway length, and then whether all these services are actually present there. You can select the units that are to be used in the EFB application, and runway length type is also something that you have to read the manual for. It basically determines how the runway length should be calculated, and the same for all the obstacle clearance stuff. So you can basically set a lot of options right here using this menu, application preferences. Right here you can also restart the EFB if you want to. This will really turn it off. As you can see, right now it's been turned off and it's loading in the background again. Okay, and as you can see, one by one systems become active again. So that's a bit of an overview of all the functions that you can find on the EFB in relation to simulation and viewing documents and setting it all up. but of course the EFB is mainly used in flight to actually do calculations, and that's what we're going to take a look at right now. So again, my route has been entered, all the weight has been entered according to the flight plan. Let's go to the EFB. What you always want to do upon your flight, when you've programmed FMC, when it's ready, is to initialize the flight. This is basically going to tell the EFB to get ready, to get all the systems ready, and it's also going to copy any data that's already available from the flight management system to copy that to the EFB. So let's click Initialize Flights, and as you can see, the flight has now been started. Of course, we restarted the EFB, so if you look at terminal charts right now, as you can see, indeed, it has filled in this information, for example, in this application automatically. Now, the data that you really want to get from the EFB is takeoff and landing calculations, and for that we need to go to the performance application. So when you click on performance, first of all you will face the takeoff performance page. And as you can see, the application is a bit hard to read sometimes because of this is magenta, but as you can see, it is already filled in some information. So it is filled in our departure airport, our departure runway, and also the weather, so outside air temperature, the pressure, and the expected takeoff weight. So this has all been entered. These magenta items have been added based off what is present in the flight management system. On the left here you have a couple of menus that you can use. You can view airport info, so you can view any obstacles near this runway if it's been added correctly. You can also view some information about the runway and about the airport itself. You can also manually add an airport, so if for some reason information is missing or you want to add a particular airport that's for some reason not there, you can do that right here. And you can also add information about the runway length, runway slope, and all that stuff, and what kind of units you want to use with that. Okay, so that can also be done, but in principle this should not be necessary. The NOTAMs page is used to enter any information that you might actually receive from actual NOTAMs. For example, if the runway is shortened due to maintenance, or maybe some sort of construction places near the runway, you can actually read that from the NOTAM and enter that information right here. So upon viewing airport info, it will notify you about that, but also the takeoff calculations will depend on that. So for example, it may be that due to maintenance the runway is shorter. This may actually be simulated on VATSIM, for example. That's actually part of the runway is closed, so you can actually enter how much shorter the runway is due to the maintenance, and this will be included in the takeoff calculations for that particular runway. So that's very useful, of course. If you want to type in that information, again, just click here Show Keyboard, and it will allow you to type it in, and then you can hit enter to confirm that. So now we really get to the part which is really about calculations. So first of all, you want to make sure that your weight and balance is set correctly. So we go to the weight and balance menu, and right here you can see the information regarding the weight of the aircraft. Now again, I've already in the FS Actions menu, I've already configured the weight of the aircraft. So you can simply, if you've done that, you can just simply click this button right here, read from aircraft, and as you can see, payload and fuel data imported from the aircraft, and then you can click OK. Of course, you want to make sure that you cross-check, make sure that all the the zero fuel weight and all that stuff is correct. So right here in the cargo section, you can see how much cargo is loaded in each of the different sections, and this should correspond to the value that is to the values that have been set here in the FS Actions menu. So in the payload section, you can see how much is in each compartment, and that again should correspond to what is in here. Then we go to the other section. Here you can add any last minute changes that are not included to your flight plan. For example, any passengers that are added to your flight, or maybe some extra pieces of cargo. You can give that a description and a weight, and that weight will be added to these calculations at the bottom right here. So for example, you can say that we have 500 kilograms extra, so to speak. You can add it right here, and then it will be added to the different weights. And what you have to add here is also a so-called balance arm. I'm not entirely sure how to calculate this. Normally you would probably get this from an actual load sheet, so it's not really something that you can enter, but just be aware this balance arm is there, which of course required to determine how much this weight is going to affect the center of gravity depending on its position in the aircraft. So yeah, it's a little bit complicated. So I'm just going to leave this empty. I'm not going to add any other information right here, but just be aware that in principle this can be added. You can also add some more information into the fuel, and this is actually very useful. Now the weights right here should correspond to the actual weights that are loaded in the fuel tanks, so make sure that you actually check out your fuel page in this case. So we can do that right here, of course. We can view how the fuel was distributed among the different tanks, and that should correspond to the values right here in the EFB. And indeed the center tank is empty, so that's correct. Now right here you do want to enter some information. You want to enter your taxi fuel. This is usually included in your flight plan using a PFPX, for example. It's estimated that the taxi fuel will be 1000 kilograms. So let's enter that. And right here you also want to put in your planned trip fuel. This is very important because, as you can see right now, it thinks that we're not going to burn any fuel throughout this flight, and we're going to land with the same weight as we take off with. But of course we're going to burn a lot of fuel during this trip. So as you can see, the trip fuel in our flight plan is about 90 tons. So we can simply enter that value here. There we go. And as you can see, we don't see the amber warning anymore. The land fuel is within limits. As you can see, between brackets you can see the maximum weight for each associating weight limit. So our maximum landing weight is 346 tons, but because we're going to burn about 90 tons of fuel throughout this flight, we're going to be landing with 333 tons of fuel, which is within limits. Okay, so always make sure that you fill in the fuel information here, the taxi fuel and the planned trip fuel. So if all goes well, we'll land with this amount of fuel. So let's hide the keyboard for now, and right here we can see the associating graph as well. So this is a so-called flight envelope. If you're flying the Dash 8, this looks pretty familiar. You know, here are the different graphs. Basically, you want to make sure that all these values are within their associating limits. So as you can see, the takeoff weights within limits, the landing weights is within limits, as you can see between the green graph, and the zero fuel weight is within its associating limit, and the operating empty weight, so the aircraft without any fuel or any payload, is also within limits. So basically you can use this graph that to make sure that the entire flight through the different phases, takeoff and landing, is within limits. So again, make sure that all these values are white. If any of these are amber, you know, if it turns out that your landing weight is going to be too high, you know, you might want to consider just loading less cargo, or maybe you simply, you know, took too much reserve fuel with you. So in this case, you can adjust that, you know, still at this stage of flight. Now, one more thing to discuss on this page, we have here the fast fuel option. Basically, you can also enter the total amount of fuel you want to have on board. So for example, okay, let's see, on our flight plan, our release fuel is 121.877. So basically what this will do, if you click complete, it will make sure that it calculates how to distribute that fuel among the different fuel tanks. Now if you're using the FS Actions menu in the flight management system, it already does that, but this is if you actually start with the EFB. Because you can also enter fuel right here, let it calculate how to distribute it, and then you can send that data to the aircraft. So that's, as you can see, a little bit different. This really depends whether you start with the FMS first or whether you start with the EFB first. Now in my case I started with the FMS, so we don't have to use that option, but just be aware that it's possible. Okay, so all this information is now correct, has been entered. The cargo and the fuel values are okay and all within limits, so let's click complete. And now we can do the calculations for takeoff and for landing. Now again, if you copied FMC data, some data will already be entered. Indeed, right here, Dubai, you can also search for airports if you want to. So for example, if for some reason you want to do that manually, you can right here search for the ident, for example, and then it will be entered right here. Now, I just want the data from the FMS, so let's do that right here. So we have Dubai, we have runway 30 right, which indeed planned, copied from the flight management system. Here we have the intersection. It's unfortunately not available here in the EFB. Basically, it allows you to calculate takeoff performance from different runway intersections. would be useful if this is included in the future, so you can actually, you know, make accurate calculations. For example, if ATC asks you if a particular intersection is available, you can easily calculate whether you actually have enough takeoff distance in order to accept that. One cheat method that you could use is go to the NOTAMs and then shorten the runway length based on how much you expect, you know, that intersection departure to be less runway. You can enter that right here, but of course it's not very realistic. So yeah, unfortunately that is not working. Right here you can enter the conditions of the runway. As you can see, there are a lot of options right here. Unfortunately in the simulator this is of course not all simulated, so yeah, it doesn't really make a lot of sense, but basically you can tell whether the runway is dry, whether the runway is wet. You can also select things like slush or snow, dry snow, wet ice, you know. All of these weather items and runway conditions could affect flights. So for example, if there's slush, if it's been snowing, it's kind of melting, you can basically enter that right here. You can also enter how deep that is, and based off the METAR report you can basically enter the depth of that slush. Alright, so really from the weather conditions you can adjust this variable. Now in this case in Dubai it's great weather, it's dry, so that's no problem. You can see the outside temperature is a little bit low for Dubai maybe, but that's because I've used the default weather theme, fair weather. Now right here you can enter the wind information. So basically the way you enter this is like in the METAR. So let's say for example the wind today at runway 30 right is 320 degrees at 12 knots. And then we click enter, and as you can see it gives you some information. So it shows you how much headwind you have and how much crosswind you have. Now we're departing out of 30 right, so indeed it makes sense that we have a little bit of crosswind with this wind. So that's some nice information. You can also enter the QNH right here, so the pressure at the airport. Now let's say the pressure right now is 1013. You can enter that right here as well. So just make sure that you cross-check with the weather information whether this is all correct, so that the aircraft can calculate its takeoff performance properly. Then we get to the reduced thrust rating and assumed temperature entries. Now this basically allows you to reduce the amount of thrust the engines produce during takeoff, and you can do it two ways or both. You can either select one of the thrust ratings, with thrust 1 being a little bit reduced N1 value and thrust 2 even further, or you can enter an assumed temperature right here, which makes the aircraft make calculations assuming it's actually hotter than it actually is, so it will produce less engine thrust. Now this is quite a complicated topic. I'm not going to go too much in depth about it because I'm not fully aware of it either. Now the very basic difference I would say is that thrust rating is kind of, you know, a safe option. Basically there are so-called minimum control speeds, so you know, for each takeoff thrust setting, you know, it's exactly calculated whether, you know, it's within the limits of your minimum control speed. But with assumed temperature you're basically manually reducing the thrust even further. So in some conditions that may not be advisable. So for example when it's very icy, you know, or very a lot of slush on the runway, then it may not be as safe as to use an assumed temperature takeoff. So by selecting one of the derated thrust settings, takeoff 1 or takeoff 2, basically you know they are calculated with the minimum control speed in mind. So for example, when there's a slippery runway, even using one of the derated thrust settings, you are assured that the aircraft is able to be handled under those conditions. While with assumed temperature takeoff, this is not really guaranteed because you're just manually reducing the thrust even further. Okay, so this does not take into account any minimum control speeds. Okay, so basically when in the real world the runway is dry, you can use assumed thrust takeoff right here, and then use one of the thrust ratings as well. But if it's very icy, or for example there's a lot of slush, or there's simply conditions which would make you know, controlling the aircraft more hazardous in general, then it's not advisable to use the assumed thrust setting. Okay, now in this case it's very dry, we don't expect any problems during this takeoff. So basically you can select one of the takeoff modes right here. So this is of course useful to save the lives of the engines. So let's say for example we pick takeoff 1, we're still rather heavy. Now here we can also enter the assumed temperature that you would want to use. If you leave it on max like this, basically it will allow the performance calculator to calculate the assumed temperature automatically, which is most useful in relation to the performance and to the runway available. You can also put in a specific value right here if you want to, for example, do a specific assumed temperature for some reason. You can also enter that right here, so then it will really use the 50 degrees assumed temperature for the takeoff. But you can also enter a minus value, and basically this will allow the system to calculate assumed temperature, but it's not going to calculate it all the way using the maximum values, but it's going to calculate all the way minus 10 from the maximum assumed temperature values. So this basically allows you to set a little bit of a safety margin so that it cannot pick the maximum assumed thrust temperature. Okay, for example, when the conditions are a bit debatable, whether it's not really sure how this is going to work out, you can enter that safety margin from the maximum temperature. If you just enter 0, it will show max, and again that means it will use any assumed thrust temperature between the minimum and maximum range. Okay, now you can do the flap configuration. You can basically select which flap setting you want to take off. You can also leave it on optimum. So just select optimum, it will turn green, and it will basically calculate itself which flap setting would be best for takeoff. You can determine whether you want to have the air conditioning on or off. Basically, if you have the air conditioning off, it will mean that the engines have a little bit more power during takeoff. So this would be advisable for short runways or when it's very hot outside, for example, if the engines really need all the power for the takeoff. But in this case, the runway is long enough, we're not fully loaded, so we're just going to have the air conditioning on. Anti-ice, you can also say when there's any icy conditions, when you expect to have the engine anti-ice on or the engine and wing anti-ice on, you can select these. Again, having the anti-ice system on board 747-8 aircraft is going to affect the performance of the engine. So basically, with anti-ice on, there's going to be less bleed air available for the engines. Now in this case, the anti-ice system will be off, so that is set and good to go. So if you've entered it all properly, and if you did enter the weight and balance before properly as well, you'll be able to see the takeoff weight and the center of gravity right here. And as you can see, the calculate button has now been illuminated, so to speak. So basically what we can do right now is hit the calculate button. As you can see, it comes up with a warning message in this case saying that there are no valid assumed temperatures available. So apparently the conditions are as such that we cannot take off with any assumed temperature for takeoff. If we select this thrust rating. So these are the results that you will see at the bottom right here. As you can see, it's determined that we calculate with the flap 20 takeoff. Acceleration height is 1500 feet. This is our trim setting for takeoff, so we want to make sure that we set that right here, once the hydraulics are active. And as you can see, it gives us also the V speed. So V1 is our decision speed. Rotate, so we're going to rotate the aircraft, and the V2 is the safe climbing speed. It also shows you the runway, our takeoff weight, our takeoff and one setting 93.6%, and then VREF. It basically shows you the in VREF, the minimum approach speed with flaps 30. If, for example, during takeoff something goes wrong, you can fly safely with this flap setting and speed. So as you can see, this is all the takeoff information. Now, of course, for fun, you could maybe try something different. Let's just select the takeoff thrust setting and hit calculate. And as you can see right now, using this setting, it actually does come up with an assumed temperature. So I'll just, for demonstration purposes, leave on this. As you can see, the V speeds are a little bit different. Our the rated thrust rating is going to be 94.6, and we have an assumed temperature of 43 degrees centigrade. So what we'll do now is go to the flight management system, and basically where I left off, I've entered the route, and now I would normally do the takeoff calculation, as you can see. So basically what you can do now is enter all the information from the EFB. So we're going to take off with regular takeoff thrust setting, but our assumed temperature is going to be 43 degrees, so we enter that right here. Okay, so let's go to takeoff. We're going to be taking off with flaps 20. Center of gravity, we can just click that. 22% should be about the same. And as you can see, the FMC also calculates some V-speeds for us. Now, if we cross-check the V-speeds, as you can see, they're quite different. And that's basically because, you know, the EFB takes into account more factors for the takeoff calculation. So it takes into account the weather, the temperature, the runway conditions, the actual wind information. So basically what you want to do is, you know, actually use the information from the EFB in this case. So of course you could just confirm these V speeds right here, but you can also enter them manually. So 163 for V1, and then rotate will be 179, V2 190. There we go. So again, the EFB is really used to include those other variables which the FMC cannot calculate, basically. So it gives you a better idea of how the takeoff is going to be. So just make sure that you cross-check if this is somewhat similar to what the EFB says. Now, as you can see, our thrust rating right here with the assumed temperature that we've selected, 43 degrees centigrade, 94.7. And we're just going to cross-check. Okay, that's about the same. I think the center of gravity is a little bit different from what's actually in the aircraft, but that's okay. So as you can see, we've now entered all the information. So the main thing that you want to make sure is that the V speeds correspond to the EFB in this case, and that your takeoff thrust setting corresponds as well. Okay. So as you can see, those are the takeoff calculations done. Now you can do the same for the landing. Right here you can select show landing, and this allows you to enter landing information. This depends a little bit whether you already select an arrival or not. If you select an arrival and you copy the FMC data, it will already show. So let's do that for fun. We can go to the departure arrival page, and then we can say, okay, let's arrive ILS 03 and then Axona 8 Alpha arrival, and then hit execute for now. And then if we go to the EFB, if we click copy FMC data, as you can see, it has entered runway 03. Although it's a little bit hard to read, I'll be honest, but right here it reads 03. So basically, like the takeoff section, you can basically enter all the information right here. So let's say the runway is dry. Okay, right here we can enter the wind information. Of course, normally you would do all of this basically during you know, your approach. Before your approach, it was part of your arrival briefing when you have the latest information. But let's say the wind is currently 100 at 10. We enter that. Again, it gives you crosswind and headwind components, so that's nice. Let's say the temperature is 22 degrees Celsius, and the QNH right there is 1025. 1025. Okay. You can again select the flap config, just like for takeoff. Right here you have to select one of these flaps though. So let's say we want to land with flaps 30 with the lowest speed as possible. You can again tell whether the air conditioning is off or on, depending on your performance. Well, we're just going to leave the air conditioning on, and we will not use NTIs. Okay. Now here we have VREF, so you can decide how much knots you want to add. Now this of course depends on the amount of headwind. So basically, if the wind conditions are such that you might want to add a little bit more of a safety margin to your approach speeds, you can add that here. But normally the default VREF is 5 knots. But for example, if you have a 20 knot headwind component, then you might want to make this 10 knots, so half of the headwind component usually. So, but by default again it's 5, so that's good. And we click calculate, and it's going to give us some information for landing. So as you can see, it presents some information right here. You can see it shows you the maximum landing weight. Well, we know we're already within limits, as we saw before. It shows you the VREF at flaps 30, so the approach speed plus 5 knots margin will give us a final approach speed of 166 knots. The quick turnaround weight is basically, as the manual defines, it's the maximum landing weight allowed without having to wait at least a quick turnaround time for the brakes to cool down prior to departure. So we have to land with less than this amount of weight in order to prevent having to wait 49 minutes for the brakes to cool. So if we check the weight and balance section once again, you can see our landing weight is 333,463. And if we go back to the quick turnaround weight, as you can see, we are within that limit. So basically it just means whenever you are landing above this weight, you have to wait this amount of time for the brakes to cool down, which is of course very important. The brakes get very hot during landing, especially if the aircraft is heavy, so you have to take that into account if you're going to make multiple flights. Okay, so this is some useful information for that. Now if the temperature is freezing, if there's ice to be expected at this airport, so let's for example enter -5 just for fun. And then if we then hit calculate, it's going to show you some extra information. So basically it shows you, when there's ice on the runway, what your maximum landing weight is and what your approach speed should be. In this case it's the same, but as you can see, the quick turnaround weight is increased basically because it's cooler outside. We can land with more weight because the temperatures are basically not heating up as much in this cool environment. So you can kind of see how the variables interact with the values that it spits out in the end. Now these results are so-called landing dispatch. So basically, these are the calculations that you would be able to do at the start of the flight. It's if you have just basic information, but of course en route things can happen and you might make certain decisions that make the calculations different. So actually what is normally used, at least what I normally use, is this en route calculation. So right here you can click show en route, and right here you can enter a lot more information, and you can also enter with what brakes you're going to be landing, and do some calculations regarding runway length available. So right here, okay, we have the same runway, Portugal, Lisbon, runway 03, conditions are dry, the wind is still the same, QNH is still the same. Right here you can include some more configuration stuff. So for example, you can determine whether you're going to be using reversers. So you can either choose to not use reversers at all, whether all reversers are operative, you're going to be using them, or whether 2 reversers are inoperative, you can only be using 2. So let's say we just use all operative, so basically we're able to use all of them, which of course upon landing will actually help to save wear and tear on the brakes. Now we're going to be landing with flaps 30, air conditioning on, anti-ice is off, that's all still set. You can also select the auto brakes right here. So basically you can select whether you're going to be landing with auto brake 1, 2, 3, 4 or max, or max manual. And usually manual brakes, maximum manual brakes, produces more brake capability than max auto. So keep that in mind that they're not the same. Okay, so let's say we're going to land with auto brake 4. And you can enter any non-normal conditions right here, so stuff that may have happened during the flight that shows up, and if there's anything right here, you can select that. You can see it provides 3 different pages right here. So if there's anything wrong, for example, if any hydraulic system has failed, if the pressure has been reduced, that all affects the landing performance. So you have to take that into account. You can easily calculate here by just selecting it how that will affect the landing. Let's say we're coming in at Lisbon, we don't have any problems, so we have nothing not normal. We have our landing weight, you can adjust that if necessary right here. So for example, if through your own calculations you've determined that your landing weight is a little bit lower, let's say it's now 333 tons, upon your flight, if you burned a little bit more fuel, you can enter the landing weight right there. One thing you have to do with the non-normal config, if there's actually nothing wrong, just make sure that you actually select none and then click complete. So again, this is something you need to do en route. Once all of that has been filled in, you can have a better idea of your landing. Basically, you can see here what your approach speed will be, and the landing distance required, and the landing distance that will be available. So as you can see right here, we have about 1,200 feet of runway available, and we're going to need about 8,200 feet for this landing using this auto brake setting. Let's say we want a little bit more margin, and we're going to put it on max auto. We can calculate it, and we can see that we use less amount of feet for this landing. And as you can see, our VREF is also different. So basically, using the latest information, using the en route landing performance calculator, we now have a definite speed that we're going to be landing at. So our VREF with flaps 30 plus 5, our final approach speed will be 163 knots, which is different from the dispatch. So here you have less information available, so yeah, it does not really provide accurate information, but the en route information, we have filled everything in, and using that calculation we can see our actual landing speeds. For the takeoff, again, we filled that in to the FMC, of course, using here the init ref takeoff. The thrust setting has been set, all the V speeds have been set. You can do the same for the landing. So when you've done your en route landing calculations, you can check the VREF, and then in the init ref on approach, right here, you would be able to select your flap speed and make sure it corresponds kind of to the flap speed indicated in the flight management system. Okay. Now again, the EFB takes into account more variables than the flight management system, so to keep that in mind. But upon landing, of course, you want to make sure that you select an actual flap setting and speed. So in this case, it would be flaps 30, 163 knots. There we go. So I hope this is a little bit clear. I hope this has given you a bit of an overview of the EFB. As you can see, it speaks pretty much for itself, although you have to be a little bit careful about what data you enter. You know, it can be a little bit complicated, so make sure that for each phase, for takeoff and for landing, you very accurately, step by step, cross-check all the information. So basically, you know, make sure that you pick a way of working. So again, my way of working is to just, you know, fill in the FMC. First of all, fill in the fuel and the payload, make sure that's all correct according to the flight plan. Then just fill in the flight plan, make sure that all the runways have been selected, the departure runway and the arrival runway has been selected. And then basically I go to the EFB, I initialize the flight, and then you know, that information is being copied, and then using the performance calculator I can do takeoff performance, and you know, when I'm en route and when I'm landing, I can do the en route landing calculations. Okay. So, but just cross-check that you verify each and every step is really important, because all these variables can affect your landing or your takeoff respectively. Okay, so keep that in mind. Now, when you've landed, you can simply close the flight if you want to. Basically, just going to delete all the information, so all the performance calculations have now been removed, and basically you can just start over and, you know, initialize your flight again for the next flight. So that's basically how that works. But again, I hope this has given you a good overview of the EFB. As you can see, it's very useful. So the main reason why you cannot just use the FMC is because the FMC simply doesn't take into account all variables, and variables change in the flight, and the EFB is very essential to make accurate performance calculations and to make the performance calculations easier. As you saw, for example, with the landing non-normal conditions, you know, can easily and safely determine, okay, how much runway do I need, with what speed do I need to land in order to make sure there's enough margin with the end of the runway. You know, especially in non-normal conditions, this is essential. But just make sure that all values and all information is entered correctly and accurately, according to what the flight plan states and according to the weather and the node temps at the airport. So I'd like to thank you for watching this video here on the AviationPro channel. I hope you have fun with the EFB. Just make sure that you play around with it a little bit, see how adjusting the values impacts the calculations. Now, if you want to see this flight in action, I actually flew this flight live on the VATSIM network, Dubai to Lisbon, so make sure that you actually check it out. It was quite fun, and there are some quizzes during that flight as well to test your aviation knowledge and VATSIM knowledge. And for now, I'd like to thank you for watching this video here on the AviationPro channel, and I hope to see you next time.